Hello and welcome to this section of the Matlab tutor, and here we're going to begin to talk about complex numbers, imaginary numbers, something that you're going to work with constantly when you get into higher math. So Matlab completely and totally understands imaginary numbers, complex numbers, very intuitively. To enter the imaginary number I into Matlab, it's just the letter I. So the bottom line is you're never going to use I by itself as a variable because I means 0 plus 1i to MATLAB. In other words, this is when you just type in the imaginary number I, the real number is 0, the real part 0, the imaginary part is just I. So that's why it translates. And every time you deal with imaginary numbers, it's going to give you a real part of 0, and the imaginary part will be listed there. What if you wanted 2i? You don't even have to put a multiplication symbol in here. It knows that whenever you put I after a number, it's 2 times I. Now you can do 2 times I if you like. You're going to get the same thing back, but MATLAB understands that if you have 44i, that you're talking about 0 for the real part plus 44i for the imaginary part. All right, so let me clear the screen. Now you can, of course, do basic addition, subtraction, all this stuff with imaginary numbers. So if you wanted I plus I, you could just literally type it in the command line, and it understands that that's 2i. 43 plus, let's 43i plus, so let's just say minus 17i, like this. So it'll do that subtraction on positive 26i. It understands that. Now, what if you have something like, these are so far been dealing only with purely imaginary numbers, but let me clear the screen. What if I had the complex number, 2 plus 3i? Of course, MATLAB understands, no matter if you have parentheses or not, 4 plus 8i, that whenever you enter something like this, these guys are added together, but one part is real and one part's imaginary, so it knows that it can't just add those, it sticks them together as the complex number, 4 plus 8i. Okay, let me clear the screen. So if you wanted to do some simple addition, 43 plus 55i, and you wanted to add to that, 13, I'm going to put it in parentheses, 13 plus 6i. And I'm just doing the parentheses to show you. This could be the first complex number, 43 plus 55i, and this could be the second complex number. MATLAB understands that it adds the real parts together and it adds the imaginary parts together. Let me recall that calculation. If you change it to subtraction, of course, MATLAB understands you subtract the real parts from one another and you subtract the imaginary parts from one another. If you strip the parentheses, everything more or less behaves the same. But you just have to sort of think about the order of operations. In this case, you have 43. It's going to be subtract 13 from that. Now the 55i is going to be added to the 6i because there's no parentheses there to tell it to do otherwise. So in this case up here, you were subtracting the entire complex number. Here we've stripped the parentheses. So MATLAB is going to subtract the real parts, and the imaginary parts, because of the signs here, are just going to be added together. So it kind of behaves just the basic rules of algebra. Now I can keep doing examples like this, but it kind of gets cumbersome typing all that stuff in. So what I can show you is that MATLAB understands complex numbers with variables just fine. So for instance, if I have a variable a, I can assign to that 4 plus 7i, okay? And of course MATLAB echoes back that a is equal to 4 plus 7i. Notice that whenever I do that, variable a is created and it tells us that the value is 4 plus 7i. That's the complex value. If you go over here, the min and max, you can't really see the whole thing. The minimum's 4 plus 7i and the maximum's 4 plus 7i. That's because we only have one value here. If we had an array or a giant list of complex numbers, then the min and max would be telling you the smallest and the largest value here. All right? So we can define b to be, let's say, 2 minus 3i. All right? So b is echoed to be 2 minus 3i, and there we go in the workspace there. So now that we have a and b defined, you can do, of course, a plus b. It's going to add the real parts and add the imaginary parts. You can, of course, do a minus b. And, of course, you can do things like a times b. Now, this is where something like MATLAB gets handy, because when you multiply these things together, what you really have is the variable a is a term, 4 plus 7i. b is another term, 2 minus 3i. So when you multiply them together, you basically have to do something like FOIL, first, inside, outside, last term, and you collect all of the like terms to get to the simplified answer here. So MATLAB's doing all that stuff in the background for you. You don't have to do it yourself. And if I wanted to divide something, a divided by b, I can of course do that as well. So that's just a good introduction to imaginary numbers and complex numbers in Matlab. The bottom line is, I can have any variable I want, 44i. I can have another variable as a complex number, 3 minus 9i. And once I have these things together, I can add, subtract, multiply, and divide. MATLAB's going to understand all that stuff. So let me go ahead and close here. Let you go ahead and pull up MATLAB, play with that yourself. This is the basic way you enter complex numbers into MATLAB. In future sections, we're going to talk about how to extract the real and imaginary parts and how to do some conversions, and also how to use some of the other built-in functions of MATLAB to work with complex numbers.